Right, some more indirect truth tables here. The full translation, and I'm not really discussing translation in this video here, that's otherwise for your exam you should definitely spend a good chunk of time practicing translations, checking your answers and asking me as you have questions, just focusing on the operators, the validity part to the puzzle, not the language part. All right, without further ado, look over here. This is a fuller translation of problem 8 in the homework. If we're to do an indirect truth table for this problem here, let's go ahead and note this is 10 star. All right, this is 8. This is still problem 8, so let's not call it 8 star, just a better translation. Now, we're trying to make all the premises true, 1, 2, 3, and the conclusion false. Premise 1 and 2 as if-thens. More than one way to make those true, as we discussed before. Premise 3, though, an and claim, only one way to make it true, and this will get us going here. We got R, it's got to be true. P's got to be true to make that third premise true. No other way that premise can be true. Conclusion, more than one way to make it false, so that's not where we would begin. What we need now to do with R and P assigned is to give that same truth value to those claims, being consistent here, so it can make sense out of the matter. All right, and those are the two places they appear. Now, looking at the first premise, we have an if-then, and the antecedent, the part to the left, is definitely true. Only way we can now make premise 1 true is to make I false. So not I is true. Okay, so that gives us then the first premise. True, assigning I false. That then pushes us to an if-then with a true antecedent again. We have to make the consequent true to save it. So we're going to have to make B and M true. Only way we can now get the second premise true. That's the only way in total we can get all the premises true. But notice what's happened here. That has forced the conclusion to be true. Just what happens with valid arguments. So make an X here. Can't get all premises true and the conclusion false. Valid. Again, apologize about the imperfect writing here. I'm relearning. Okay, number 10 star. Let's go to it here. I modified the old problem 10. Where we need to begin here, no forced options other than, in this case we have not L with an and, we need both parts true, both conjuncts true, so L, as a matter of fact, has to be false. That's where we begin. Conclusion again with an and, two different ways. It can be false, which is the question. However, we can proceed here. Instead of doing a 32-row truth table, we can do this pretty quickly. We have L as false. Now that fixes what has to happen in our second premise. We must make I false with an if and only if. Both expressions have to have the same truth value for it to be true. So once we have L true, once we have L false, we have to make I false. Sorry about that. Now we do indeed have the second premise true. Proceeding, I is false wherever else it appears. That's these two places. All right. Now, look at the first premise. We think about the operators, and again, you have to understand the operators more precisely. Parentheses as well. With the parentheses, the expression in parentheses here as a conjunction with the first conjunct, first part of it false, we know is false. So we have an if-then for our first premise, and the consequent, the second part, we know is false. Only way to save it is to make the first part false. R's got to be false. That then fixes our first premise as true. Then we know that R is false. The rest is going to fall into place here. With R false, two things happen. Let's go to the somewhat simpler part first. Now with R false, not R is true, if we're to have our conclusion false, Z is going to have to be false. And this is how we would proceed. That then gives us our conclusion is false. We could write it up here. We should write it up here. But that first premise was already true. It didn't matter. And this doesn't change anything. All right, now B is the only thing left. Can we assign it such that we get all true premises and a false conclusion? The answer is yes. We need the expression in brackets here. the if not be or I then are to be true, because it's an and expression. It's the main operator in the third premise. With a false consequent, we have to make sure the antecedent is false, and we can do that by assigning B true. We must make B true, but then that does give us all true premises and a false conclusion. If you look below, you will see I have written out the assignment of truth values that gives us all true premises and a false conclusion. We need to cut this off.